Hello and welcome back to the course. Our Dungeon Gunner game development is moving forward steadily, and in this section of the course we're going to look at some essential functionality for any dungeon shooter. We're going to cover player shooting and creating the weapons and ammo to support that. In this lecture, we're going to start by looking at the weapon and ammo classes that we're going to use to support this functionality. It's really important before we actually launch into the code that we fully understand how our weapon and ammo classes all fit together to support the functionality that we need to create. The first two classes that I'm going to look at are the weapon and weapon details classes. The weapon details scriptable object class is a class that holds all the weapon details, for example, the weapon sprite, the weapon shoot position, the current ammo for the weapon, any shoot effects, and the ammo capacity, etc. The weapon class references the weapon details scriptable object class, and the weapon class represents an instantiated weapon, and it contains details such as the total ammo remaining and the clip ammo remaining. In these slides, I'm going to represent existing classes using a blue box, and I'm going to represent new classes that we're going to be creating using these green boxes. So in previous lectures, we talked about events and publishers and subscribers for events. To implement the shooting functionality and weapons and ammo, we're going to make extensive use of events. By doing this, we'll keep the functionality modular and decoupled, so that it's easily expandable in the future, and it's also easy to understand how all of these components fit together. When we implement the event functionality, we're going to use exactly the same patterns that we've used previously. So in this slide, you can see the classes that we're going to be creating to enable the weapon to be fired. And if we start off by looking at player control, we're going to amend the player control to monitor for player firing input. So once a player fires, we're going to publish an on-fire weapon event. So the fire weapon event component is a mono behavior component for the on-fire weapon event. And we'll also have a method called call fire weapon event exposed to publishers. So this is the same pattern that we've had before. So we have an event and then we have a method that publishers can use to actually trigger that event. So in the center here, you can see the core fire weapon class, and that's a mono behavior component that subscribes to the on fire weapon event. It handles the firing of weapons, including initializing ammo to be fired, firing multiple ammo if configured, the shoot effect, the shoot sound effect, and managing shoot cooldown timers. The active weapon class will supply the fire weapon component with weapon and ammo details. The active weapon class is a mono behavior component used to set the active weapon and return details about the current weapon and ammo. So when a weapon has been fired, the fire weapon component will publish an on weapon fired event. And again, the weapon fired event class is a mono behavior component for this event, and it also has a method exposed to publishers called call weapon fired event. So as well as firing weapons, we want to have the functionality for the player to be able to reload weapons. And to support that, we're going to create a new on reload weapon event. And we'll do that using the reload weapon event class, which is a mono behavior component for that event. And again, we'll expose a method called call reload weapon event that publishers can access. So weapons can be reloaded in two different ways. First of all, the player control script is going to monitor for player input for the weapon to be reloaded, and we'll do that by the player pressing the R key. In addition to that, we'll also have the fire weapon component also generate an on reload weapon event when the weapon clip is empty and the player attempts to fire the weapon again. So once we've generated a on reload weapon event, this will be picked up by the reload weapon class. So this class is a mono behavior component which will subscribe to the reload weapon event, and it will handle the reloading of weapons. And then we've got another event called on weapon reloaded, that is going to be implemented in the weapon reloaded event class. And when the reload weapon component has reloaded the weapon, it will publish the on-weapon reloaded event. So we've talked about firing the weapon and reloading the weapon. And another thing that the player will want to better do is switch the weapon. And to support that, we're going to create an onset active weapon event, and the active weapon class will subscribe to that event and respond to that event by switching the weapon. So to generate that event, we're going to have the player control monitoring the player input to switch the currently active weapon. And when it detects input to switch the weapon, it's going to publish an onset active weapon event by using the callSetActiveWeaponEvent method in the setActiveWeaponEvent class. So we're going to give our players two ways to switch weapons in the player control class. Firstly, they'll better switch weapons by using the mouse scroll wheel, but they'll also be able to switch weapons by using the numbers on the keyboard. So we've looked at firing weapons, we've looked at reloading weapons, and we've looked at switching weapons. And what we also need to do is provide some feedback to the player about exactly what's going on with the weapon that they're currently using. So to do that, we're going to have a weapon status UI. And to support that weapon status UI, we're going to create a new class called Weapon Status UI, and that's going to be a monobehavior component handling the display of the currently selected player weapon, including the clip ammo remaining, the total ammo remaining, the weapon details, and a reload bar that will be triggered when the player reloads the weapon. So because we've used a modular event-based approach, we can easily implement a weapon status UI by having it subscribe to the weapon events that we've created when we've implemented the other functionality. So the weapon status UI is going to subscribe to the setActiveWeapon event to show what the current weapon is. It's going to subscribe to the weapon fired event to decrease the total ammo and the clip ammo. It's going to subscribe to the reload weapon event to trigger the reload weapon bar, and it's going to subscribe to the weapon reloaded event so it knows when the weapon reload has been completed. So that's our complete model for the weapon classes, and I would recommend as we go through this section of the course that you revisit these slides just so you can fully understand how all of these classes fit together as we start coding this functionality. So we've talked about the weapon classes, now I'm going to talk about the ammo classes, and you can see here we've got 3 ammo classes that we're going to create. First of all, we've got the ammo details scriptable object class, and that will hold details of the ammo, including the ammo prefabs, the ammo material, the hit effect prefab, damage, speed, and range, etc. The ammo class itself will be a monobehavior component that implements the iFireable interface, and I'll talk about that in a little bit. This component is used on ammo game objects created from ammo prefabs in the object pool. The component handles the initialization and enabling of ammo prefabs, setting the ammo fire direction, dealing damage when the ammo collides, and any hit effect that the ammo might have. So I mentioned that the ammo class implements the iFireable interface. So interfaces are just a way to make sure that classes actually implement certain properties and methods. So normally a class can only inherit from one parent, but interfaces provide another way to make sure that a particular class implements certain functionality. So whereas a class can only inherit from one parent, a class can actually implement multiple interfaces, and these are just listed after the class definition. And we'll see that when we come to create the ammo class. So the iFireable interface will have 2 methods that any class implementing it will need to implement as well. And one of those methods will be to initialize the ammo, and the other method will be to return the ammo prefab game object. Another benefit of using interfaces is that rather than having just one ammo class, we could have multiple ammo classes. And as long as they all implement the iFireable interface, then in our code, we can just make sure that we've got an object of type iFireable. And as long as we do have an object of type iFireable, then we have all the methods that we need to actually fire the ammo, namely initialize the ammo and return the ammo prefab game object. And we're actually going to do that by having in the future another ammo class called the ammo pattern class. And that's going to be able to fire multiple patterns of ammo. And we're going to again have that implement the iFireable interface. So within our code, all we're concerned about is whether the ammo actually implements the iFireable interface, not which particular type of ammo class we're dealing with. But we'll see that in the future as we come to implement ammo patterns. So those are all the weapon and ammo classes that we're going to implement to support the weapon and ammo functionality that we need for the game. And as I said before, I strongly encourage you to revisit these slides as we progress through the actual coding so that you can fully understand how all of the classes fit together. Okay, so that's it for this lecture. Thank you very much for following along, and I'll see you in the next one.